All right, we should get started. You may remember that we were discussing our salivating dog. And that this is the canonical example from Pavlov's original work. Pavlov really did work with salivating dogs. And so there are a bunch of, psychology jokes that revolve around salivating dogs, and they really are all grounded in this work. So the reason I bring it up again here is we're now going to go from this framework, which I'm going to go over again just one more time for refresher, to some more kind of interesting and applied features of this. And if you can keep this framework in mind, you can make sense out of it. And then if you kind of lose the original framework, then it gets really hard. Okay. So as you may recall, initially, what Pavlov was trying to study was presence of food of different types, triggering in a physiological sense a response of salivation, and indeed the details of that process. So the actual stuff in the food would be varied, and then the products in salivation meant to break down that stuff would be studied. Right? So that relationship. What got in the way, of course, was the presence, not actually of a bell initially, but of the sound and sight of the research assistant coming in a contiguous fashion with the presentation of the food, which then got a psychic, that is a psychology-based, a non-physically based salivation event that could happen even without the food being there. And Pavlov, being pretty open-minded guy, said, this is really interesting. We now have something that was meaningless, and eventually he replaced the event of the person with the bell, something that's meaningless, coming to give us a previously physiological thing. It's a form of learning. It's kind of a way of you expanding your behavioral repertoire to other things in the environment. So now I know that when bells, at least in this experiment, when bells sound, food is likely, and so I salivate to kind of give it a rationalist framework, you see what I mean, right? So that's like reasoning about it, like go that way. Okay, so this, we haven't written this down. I don't have this somewhere. Put it down someplace, okay? Because you'll be like, that's the what in this system? It really does get confusing, okay? I don't think I've managed to screw it up yet, but that will be the first time ever that I've given these lectures without starting to flip these around. So when I start flipping them around, somebody says, no, I think you got that wrong. So this is our basic framework. And does anybody have questions about it? Maybe I should go over these terms: unconditioned stimulus and unconditioned response. Unconditioned stimulus, unconditioned response. Seems like a very long word for something that is just like straight up fact of how dogs are. Okay? And that the unconditioned nature of it kind of presupposes that indeed there's going to be some conditioning happening. And the conditioning is, of course, now the pairing of the food and the bell. That's the conditioning. And that gives us a conditioned stimulus and a conditioned response eventually. Right? So there's kind of this intermediate time during which you're picking up these relationships, so to speak, between food and bell. Right? And one of the weird things is that in this particular case, and it doesn't always happen this way, the unconditioned response and the conditioned response are the same. Turns out they can be different from each other, which confused the heck out of people initially, but then we figured it out. Questions on this little pair? Yeah.
So the unconditioned, you could say the unconditioned pair represents the physiological response, while the conditioned
Yes.
stuff represents associative learning. So
Yes. So the comment was, you could say that this unconditioned pairing, the unconditioned relationship here, represents a physiological response. That's absolutely how they thought about it. And that this pairing is the result of or represents the conditioning. That is true, although this, of course, this conditioning is like riding on physiological. Okay. Because you can ring bells all day and you don't want salving. Anywhere you can do something. Okay, so far so good. Other questions? Go on a little bit. Definitely a long person. Sure, only works when I'm standing right there. Then it's a mark. Chronic, perhaps. Try that. So I lost that. Okay. All right. So what am I doing here? So we did this. So eventually, after a lot of pairing of unconditioned stimulus with kind of to be conditioned stimulus, we end up with the conditioned stimulus, which is going to be the bell, getting the conditioned response. So the bell alone, even without the food, now gives us salivation, right? And that seems like very strong evidence of learning. So that's the kind of emergence of the conditioned response out of these repeated pairings of unconditioned stimulus and conditioned stimulus. Okay, so that's hopefully more of what I just said, just refreshing your memory. I promise it's going to get confusing. So in the acquisition phase, we can think about these as conditioning trials or acquisition trials, they're sometimes called. We have salivation measured in drops of saliva. This is from the original work, right? You couldn't get away with measuring things in drops of saliva anymore. And then these are acquisition trials. And this is a quote from Pavlov's original work. Initially, the dog did not salivate in response to the sound of the bell. By the third conditioning trial, however, the conditioned stimulus, the bell, had begun to elicit a conditioned response, salivation, which was firmly established by the fifth or sixth trial. And you can see the data seems to kind of support that up here, fifth or sixth trial. You know, you're more or less flat. You have a little bit of fluctuation, how much saliva, actually amazingly constant amount of saliva. So each pairing of the conditioned stimulus and the unconditioned stimulus is what we call a conditioning trial or an acquisition. And sometimes this is called a learning curve, which people talk about. And I'll just, so in common usage, when you say something has a steep learning curve, usually what you mean is that it's hard to learn. Technically, it's actually the other way around. If something has a steep learning curve, you learn it in very few, usually trials or some measure of time or experience down here. It's actually very easy to learn something has a steep learning curve. Something has a shallow learning curve, then it's hard. So if you want to be pedantic at a party or something, it's a good activity. So this is an example of a learning curve from Pavlov's original work. Make sense? Seem reasonable? You can see that in this case, it's happening very, very quickly. He's hit a particular sweet spot for dogs. Dogs are really good about learning about food. So here are some little detailing things about classical conditioning. Not too many. There are a lot of them. People have spent their entire lifetimes trying to understand this process in various and sundry ways. So a little bit about acquisition. As you are acquiring the relationship between the unconditioned stimulus and the conditioned stimulus, that's the acquisition. That's what we call acquisition, right? And the conditioned stimulus like slowly comes to stand in for the unconditioned stimulus. Conditioned responding rarely occurs after a single pairing, but in some cases it can. And you can see it happened very quickly for the dog. It wasn't a single sometimes we call it one trial learning. The response, generally speaking, increases with successive conditioned stimulus, unconditioned stimulus pairings. Okay, so hopefully these abbreviations are starting to get a little bit of meaning for you, right? Conditioned stimulus, again, bell, unconditioned stimulus, big slab of steak, food of some sort. Okay, so far so good. So this I'm gonna hint at now, and then we'll come back to it. So it turns out, down the road, not for Pavlov, but down the road, they began to notice that the timing of the presentation of the conditioned stimulus and the unconditioned stimulus, the bell and the food, is important. Learning works better, conditioning, synonymous, works best when the bell actually occurs slightly before the food, when the CS occurs slightly before the CS. That gets you better learning. And I'm just going to tell you the answers. Because they think the system is trying to predict what's happening. The organism is trying to predict what's happening. To the extent that it's predictive, you get better learning. So we're going to kind of run in another law of learning, or at least they're going to, they had a big fight over whether there should be another law of learning. So that's acquisition. And that we can think about that as the first thing that you can do, right? You have to acquire the learning initially. Once you have the learning, one thing that will happen, kind of as a consequence, without any, you don't have to do anything extra, is you'll get generalization. So generalization is a kind of just a consequence of doing learning. And the phenomenon is this: other similar stimuli, similar to the conditioned stimulus, so things that are like the bell, will get the same or similar response that the bell gets. So if you have one bell that goes tinkle, 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 and then you have another bell that goes tinkle, winkle, tinkle, twinkle, or whatever, right? So it has a slightly different frequency or something, sounds a little bit different. You'll get a response. If you measure really finely, you'll notice that response isn't quite as strong. There's like a little bit of falling off. So we could have other tones. We could have, in the case of the bell, bells with slightly different pitch. Right? And so we get generalization, which is kind of interesting because, of course, we get generalization in regular learning situations as well, like in everyday life. We can also get, if you have generalization, you can make it so that you get discrimination. So you can teach the dog by using bells that get reinforced, bells of different tone that don't get reinforced, to discriminate one bell from another super effectively. And so people have, maybe you see the opportunity already, people have used that to say, oh, well, how fine a discrimination can your sensory system make? You being a dog or a bird. So when you do the pairing of conditioned stimulus and unconditioned stimulus, bell and food, I'll do that, I'll keep doing that till you really get annoyed with me. The responses become stronger, and you can pull out that particular tone. It's different tone, right, where you present the conditioned stimulus, but you don't, right, so there's a minus here, so you don't get the unconditioned stimulus with that at that point, then the responses become weaker or prohibited. Okay. So it's very easy to get discrimination. You just pair some tones and don't pair the other tones, and the creature starts going, well, only to those tones am I going to salivate, not going to waste all that good saliva. And so that's discrimination, right? And you can see why it kind of follows from generalization. Question so far? The last thing, last little detail-y thing that I'll tell you about application from two different ways is extinction. it is possible to kind of unlearn these associations. So you can imagine that in the real world, things sometimes predict and then they stop predicting. So your system's kind of ready for that. And it does this thing where if you start presenting the conditioned stimulus, the bell, without the unconditioned stimulus, the food, you learn that too. And you essentially put away that, suppress the learned association that you just got over in the acquisition phase. See what I mean? So you can get rid of this. It's called extinction because, and it's weird. They decided, it's not just, if it just went away, that would done. But it turns out that what you're doing is you're sort of keeping it in the background, and then it's available really quickly should that condition come about in the world again. So you indeed stop salivating to the bell. If the bell is no longer paired with the food, after a few trials, you'll be like, no more of that. Okay. But then if you pair them again, the relationship will come right back on as if it was never, if it had never been extinguished at all. So it's like the linkages are still there in a way, but there's like an override on them. Because, not right now. Ready for it, but not right now. So the system is actually really quite sophisticated. You can also get spontaneous recovery. So it's as if the bell, so you do the bell, so let me describe the situation, make it more clear. So you do the bell, pair to the food, bell pair to the food, you get the relationship. Then you do the bell alone, the bell alone, the bell alone, the bell alone. All right, so you have learning first, and then you have the bell alone, slow extinction, okay? Then you take the dog, you put the dog back, back in its cage, back in the lab, and you come in the next day and you try the bell. Now, the last thing you did was extinguish the relationship, but you'll get spontaneous recovery where the dog's like, oh, food, right? So they'll salivate to the bell, right? So that is a situation where you haven't really done anything, but it's like the system is kind of renominates the association as a possibility. It's called spontaneous recovery. Questions on all of that? That's the tour of some of the things they found. So dogs, bells, I mean, this is, you can see the applications for dog training perhaps, but it doesn't seem perhaps like it has a, real connections to our lives. But the grand vision of the behaviorist was that, oh, it does. This is how, not the entire how, but part of how your physiological responses that are like built-in and automatic extended out to the world. Cover other things other than the few things that you have immediate physiological preferences for. So that's the overarching story, and I'll discover slowly. I'll go by starting a couple different ways. So here, we'll start with this one. So one place where this seems like it's an explanation are things called conditioned aversions. You and pretty much almost every other creature that at least kind of does mobility and consumption of things seems to be capable of these conditioned aversions, which, that's some really bad wording, extremely crucial. Something is either crucial, to be extremely important. I don't think anything can be extremely crucial. It's really bad. Anyway, on we go. You can get these aversions, and they are a good thing from an evolutionary perspective. So a lot of aversions come from for creatures like us at least, come from the relationship between smell and taste. And so these things can help us avoid poison. So, for example, so if you get sick from a particular food, you can develop an aversion for it. Have you ever had this happen, right? It doesn't even have to be related to the food, but it can be like food poisoning. But it could also just be like the onset of flu. So when I was a kid, I got some sort of stomach bug right after I had had a cheese and pepper omelet, green peppers and cheese to this day, because I'm really sick on it. Super nasty. Right, so I have a conditioned aversion to that, and it's very easy to get those. So that kind of conditioned aversion is supposed to be helping you stay away from things that aren't good for you. So some people have argued that this is kind of a universal amongst those of us who consume a variety of things out in the world to survive. One explanation that I'm not going to go into, but it has been focused on a lot in the clinical literature, is phobias. So phobias are thought to be a conditioned aversion that is not particularly adaptive, although maybe there's some good reason to be afraid of things if the fear doesn't cost you much. You can develop a fear of a specific object or situation, and this is supposedly about a pairing of an intense fear with something which is generally maybe not neutral, but certainly not as scary as you think it's going to be, like spiders and wasps, things like that, where you're kind of like, oh, that could be unpleasant to be stung by that, but generally they don't, they're not really as life-threatening as your emotional reaction seems to suggest. So this kind of idea that you are building a set of emotional responses out of very basic physiological responses is where Pavlov met behaviors in a person, and mostly through the work of this guy, the very flamboyant John Watson. Okay, so Watson was part psychologist, part vaudeville show, bigger than life, really interested in pushing this position, but the position was not uninteresting. So the idea is that Pavlovian conditioning, as we've just talked about it, could actually be used to explain emotion. So the big idea is that emotional conditioned response is kind of a learned response through this kind of pairing, in the same way that we're pairing the bell and the food. So the base case, the illustrative case, is supposed to be the baby and the mom, generally speaking, are in a relationship where the mom is nursing the baby. So the baby is having a positive physiological experience, right? Going from a state of, man, am I hungry, to, wow, that was super yummy, in the physical, tactile, olfactory presence of the mom. See what I mean? Like, you are like in the complete mom experience here, right? Because you're warm, you're nuzzling, you're doing the breastfeeding thing. But the breastfeeding thing only gets its strong emotionality. This is the strong point that Watson's trying to make, from the transferring of the positive emotionality of, wow, that was really good, and I'm not hungry anymore, to the conditioned stimulus that is the mom. So the unconditioned stimulus, in this way of thinking about it, is the satisfaction from the right. So you are getting fed. Right? It's food in the same way that it is in the Bell situation. Right? You are getting fed, and your unconditioned response is great. But the conditioned stimulus is the mom context. You know, not be very romantic about it, but the mom context, right? Which now gets a conditioned response of to the mom. You with me? You don't have to believe me, just understand what silliness that Watson is trying to push. Right? I don't think this is probably true, but this was the idea. Okay, so Watson said, not only can I explain emotionality, but he made this claim: give me a dozen healthy infants, well-formed, and my own specified world to bring them up in, and I'll guarantee to take any one of them at random and train him or her in modern day to become any type of specialist I might select. Right? So basically saying the environment I know how to control now because I have the power of Pavlovian conditioning, and I can have their emotionality kind of extend out over onto anything, any action, and there was actually more to it than just emotionality. Right, so that was the idea. It was a grand claim, and it made a lot of for some reason, it was like the right claim for that moment in time. You know, like it met with people, and it. So he was famous for making this claim. I don't think anybody in the modern day thinks that this is an explanation of human emotionality and its development. But back in the day, they wanted a general explanation like this. This was what they had available. Sensible questions on this? So that was a radical claim way, way back. Much more recently, and I think on a firmer and better empirical foundation, is some modern work on drug tolerance, which is interesting and confusing and tantalizing. I'll try to describe it to you. Hopefully you'll see like this is a possible application of this thing. So one of the phenomena that is strange in drug addiction, drug use, is that you become tolerant to drugs, but you can also become oddly not tolerant, like in a moment's notice. And that's kind of paired with another weird phenomenon, which is like we take somebody who's having a drug problem, we move them out of that situation and put them in like a rehab situation. They recover, and then they don't have any more withdrawal symptoms in this place, in the rehab facility. And then they go back into their life, and the withdrawal symptoms start again. Just seems weird. Like, why would that happen? Why do I have a re-upping of withdrawal symptoms? So, a fellow by the name of Shepard Siegel proposed this very radical interpretation of drug tolerance and other drug phenomena as offshoots of classical conditioning. Very, very clever. And there's some interesting work that goes with it, and then it actually raises some other questions about, like, what the heck is this classical conditioning stuff all about, right? So it actually gets back to the theory. I'm not going to bore you with the whole story, but I'll tell you this little part of it. So here's the entryway into the Siegel way of thinking about things. So what Siegel suggests is that the unconditioned stimulus, like the food, right? Like the food in the dog and bell situation, is taking the drug itself. Okay? In his work, it's going to be morphine or something like morphine, right? So he's working with rats. let's just say it's morphine. Okay, so we take the morphine, this is the unconditioned stimulus, and injecting it gets you particular physiological changes. So morphine injection is like the food, right? And the reason we add injection there is because you're not eating it, right? It's important to know how it's going in. But otherwise, it's entirely like the food. We could have said that that food is really the consumption of the food, like is the unconditioned stimulus. And then there are these physiological changes. So what happens when you put morphine in your body is your body goes, whoa, 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 what the hell is this stuff? And tries to deal with it in some way, right? Tries to essentially metabolize it. And in doing so, produces a bunch of physiological changes, some of which are associated with its what are called analgesic effects, that are pain relief effects. Okay, so the unconditioned stimulus, the drug injection, the morphine injection, gets an unconditioned response, which are these physiological changes about counteracting the drug. So far, it doesn't look like it's going right. So generally speaking, this wouldn't necessarily have to be true, but it seems to work in the case of morphine. If the drug is an analgesic, that is making you less sensitive to pain, being an analgesic, you're taking something to reduce pain. Morphine works this way. The body's reaction is usually to reduce those processes so that you actually become more sensitive as part of as a consequence of the unconditioned response. So if the drug is analgesic, the counteraction to it, part of it is hyperanalgesia, making you more pain sensitive. Okay, hyperalgesia, I guess. Okay. So, okay, now we're going to repeatedly pair. We're going to bring in a conditioned stimulus or a to-be conditioned stimulus, just like the bell. So if the unconditioned stimulus is the drug injection, and there's nobody there with the bell, which I guess the drug user usually isn't, it turns out that just the context, what he's calling the environmental context, can act like a conditioned stimulus, like the bell acts. Right? And that turns out to be true. We already knew that from a whole bunch of other work, right? The bell, sure, the bell is like nice, discrete thing, right? It happens. But it turns out other aspects like the color of the walls and the time of day and all sorts of aspects of context the dog is also sensitive to. Okay, so we already knew that context worked this way. Right? So we have the drug injection. If it happens in a particular context, the context starts to become a conditioned stimulus. Okay. So now here's the part where it's going to get easy to be used. That seems a little strange. Now the environmental context itself gets a conditioned response. We're going to say for now, there's other work that's going to contradict this in various interesting ways, but what for us, we're going to say that our conditioned response, hyperalgesia, is going to be just like our unconditioned response, which is hyperalgesia, right? So the environmental context, even without the drug, just like the food now, I mean, the bell gets salivation, the context gets this hyperalgesic response. You now become more sensitive to pain. So thus, because you are having, you're essentially, the system saying, oh, I've learned, here comes that stuff I need to fight against. And you start pushing out like, okay, I'm ready to metabolize the drug. And part of that is you have a hyperalgesic response, and you also are more ready to deal with the drug than you would be without it. With me? So that's what he's saying is going on, okay? So this is only part of, it's not the entire story, but it's part of what drives the tolerance for the drug, right? Because the learning actually is engaging your system to be ready to fight the drug. Because it has to fight I mean, even though you may want it, it has to fight the drug. That's how it gets back to its kind of homeostatic condition. Okay? So this is sort of the explanation of why this is mapping onto this. So let's say that I'm taking the morphine injection in a particular room in my house. I take it in my bedroom. So my conditioned stimulus, I go to the bedroom, take the drug. And then I take the drug. I have my unconditioned response. Because I've paired these guys for a while, right, the bedroom alone gets me these physiological changes and gives me better tolerance. So because I'm in the bedroom, my system is ready for this. With me? And that is, for the Siegel's way of thinking, all due to just regular old classical condition. Nothing fancy, it's a learning phenomenon, kind of interesting. You usually think about all this drug stuff that's happening like at a physiological only, there's no kind of place for psychology. Okay, questions on all this so far? Food, bell, all that is mapping onto this hopefully for you. So this is the idea. I would admit, it's kind of a wilding, a little bit, maybe even goofy idea. But Siegel went on to test it for his whole career. I'm going to take that one experiment. Okay, so he did this a lot and had epic confrontations with people over, because you can see people may not like this if you are, from a different physiological perspective. You'd be like, what? Learning? Get you psychology people out of here. So one of the obvious problems here, or say that, consequences, is what happens if I remove CS? What happens if I take the drug outside of my bedroom? Well, in the face of the tolerance that I'm getting, both probably from two sources, both like a straight up physiological source. Maybe I'm just better at metabolizing the drug, right? That's one possibility. But I'm also getting the boost out of this conditioned response. Well, if I'm not in my bedroom, I'm not going to get the conditioned response. So the conditioned response is part of my tolerance to the drug. So if I don't have this, and I'm feeling like, well, I've got the tolerance and I need my analgesic effect, I might take more drug than I can handle without the benefit of these physiological changes. You know what I mean? All right. So without that conditioned response, my net tolerance is going to be lowered, and overdosing can occur more easily. So by taking the drug in a different context, which doesn't seem like it should matter, right? If I go, I'm going to go to the basement. I'm going to go to the kitchen. So if I remove the conditioned stimulus, then I lose the conditioned response to the extent that that's a major part of my tolerance. My having up the dose and up the dose and up the dose can now become dangerous. So that, again, we're still just kind of armchair theorizing here. So what Siegel did was actually really pretty clever, and it's just one of a bunch of things that he did. So he took rats and he randomly assigned them to 3 conditions. And this is, trying to essentially say that drug tolerance built up through classical conditioning, right, and then the removal of the CS is an explanation of overdosing. So he takes rats and he randomly assigns them to these very simple conditions. The first one is we're going to call the kind of the same condition. Okay. So these guys are going to get the same environment for a set of early injections, which is going to happen over 4 days, and then a test injection, where the test injection is a whopper dose. Okay. So not a really long period during which they can develop a tolerance. But it turns out it's going to be enough. Okay, so we have the key thing is same environment for the early injections and for the test injection. Okay. The second condition, we're going to have a different environment for these early injections, which we can think about as either the conditioning or the acquisition trials, and the test injection. Right. So we're going to have one context for acquisition, and another context for test. Test. So there, conditioned response isn't going to be available. And then we're going to have a control, which is not the condition you want to be assigned to, which is going to be the test injection only. Okay, these guys, no opportunity to get conditioned at all to develop any tolerance, physiological or otherwise. They're just going to get hit with a massive dose of, I think he's using morphine in this. Again, they're actually using heroin in this case, not. Okay, so early injections, as I said, are over 4 days, and they're relatively lower dose. And then the test injection is a very high dose. Okay. So the crucial thing is right here between the same and the different contexts. And this is kind of a bummer of a dependent variable. It's their mortality. Okay, so whether they died or not from the large dose. So when the environments are the same between early and test, you have kind of like 30 plus % mortality, right? But when they're different, right, you're way over 60, almost twice as much. Right? And then the poor control animals, without any tolerance buildup, this was not a good seed. This was not good for them. It basically, the survival was very, very low. So again, the point here is that with the same environment where you have the CS, conditioned stimulus, conditioned response, CS is giving you that conditioned response, that part of tolerance is available. You have a much higher survival rate than when you have different context. The CS that you've used is no longer available. So you don't get the conditioned response, you get just your physiological response. Whatever tolerance improvement is not due to learning, right? That gives you a better life expectancy than the control, but still the mortality rates are much higher than in the same. So the controls had no tolerance built up at all. The different have some tolerance, but they don't have any contribution, or maybe just a minimal contribution from the conditioned response, right? Because we've changed the conditioned stimulus. And then the same have the best survival rate, presumably because the conditioned stimulus is maximally the same. So we have the best conditions. Okay, so this seems like a nice way of showing how this framework can explain some things that, initially like, what? How could you drug tolerance? What could this possibly have to do with drug tolerance? right? But it very cleverly goes in and shows you that there's a learning component, perhaps, still a little bit controversial, but I think it's probably mostly on solid ground. There's a learning component to this kind of phenomenon, and one that actually could be very dangerous for people. They can unknowingly change their context, not get the conditioned response, right? And then suddenly they're not ready to deal with that with high doses of drug. Okay, questions on any of that? Time. 6 seconds to 6. No? All right. Questions because you're so confused that you have no idea what I'm talking about anymore, or is it just clear? Maybe in the middle. Okay, let me wrap up this a little bit on classical conditioning. So there are lots of questions that still remain about classical conditioning. Lots of people in modern day don't like this extension of classical conditioning into the complex behavior that humans are capable of, right? So we're capable of all sorts of nuanced things. And it doesn't seem like just pairing stuff together, right? So they're kind of relying on chains of conditioned stimuli, pairing together, and eventually giving us a whole array of responses to many, many different things. It just doesn't seem like this is going to be powerful enough, and people have kind of called the behaviors out on this. This is not going to do. So that's one issue. You also might ask, like, what sort of laws of learning, going back to Hume and Aristotle, seem to be at work here? So that's another issue. We'll say more about that in a second. And finally, what is actually being learned? What is the stuff that's being learned? Which is always an issue in these learning theories. So what's learned? Well, the answer is always, in theories of learning, associations. Something and something go together now. Okay? So one possibility is that it's stimulus and a response. So conditioned stimulus to conditioned response. And another, maybe not completely orthogonal answer is that it's stimulus learning, conditioned stimulus to unconditioned stimulus. All right. And you probably, if you were paying attention, you'd kind of notice I was kind of hedging with people. Say, well, when people were asking me about what's being learned here, it's not so clear. So am I learning that this conditioned stimulus should give me a particular response? Or am I just learning this conditioned stimulus can be used to kind of stand in for this unconditioned stimulus? So that is still an open question. So what sort of laws are we talking about? Well, one law that we might have appealed to, and that they did appeal to, was the law of contiguity, right? So the idea here is that these things are kind of hanging together in time and space, right? The bell and the food happen pretty much at the same time. That's kind of contiguous, okay? But it turns out that the order of things, as I alluded to before, actually does matter. So if the conditioned stimulus is before the unconditioned stimulus, right? It turns out that is better than if the unconditioned stimulus is before the stimulus, but before the conditioned stimulus. But according to contiguity, that shouldn't be true. Right? All of the stimuli should be equally applicable. And finally, so rather than contiguity, sometimes people talk about, and then I'll let you go, the law of prediction, or they talk about it as a law of contingency. So that associations are only good, are sort of driven by allowing the animal to predict the situation. Right? So that to the degree that the conditioned stimulus, let's say the bell, is informative about what's about to happen, the animal learns. if the food has already been presented and then you present the bill, the animal doesn't learn so well. So maybe a prediction or contingency is better than continuity. All right, I gotta let you go there. Thanks for your kind attention.